हेलो फ्रेंड्स, वेलकम बैक। सो आज शुरू करते हैं अपनी टेलीकॉम की एक नेक्स्ट सीरीज जिसमें सिलेबस हमारा रहेगा एसडीएस सिंक्रोनस डिजिटल हायरार्की, देन वी हैव सोनेट एंड देन वी हैव एडवांटेजेस एंड डेटा रेट्स. So in most of the telecom companies, SDS plays a very crucial and important role. So I will majorly focus on SDH a lot. So in previous video, we have seen that advantages and application of PDH, that is Place Synchronous Digital Hierarchy, but it has some major limitations that we have already discussed in previous videos. So SDS removes the limitation of PDH, offer higher transmission rates and introduces many features such as FCAPs and all. So basically Sonet, that is Synchronous Optical Network, defined by ANSI, American National Standard Institute, used in United States of America, and in ITU standard, that is International Telecommunication Union, defines synchronous digital hierarchy SDH for worldwide uses. All equipment are synchronized to master clock. SDH and Sonet are similar and are compatible for internet networking. High bandwidth, low loss optical fibers used for transmission. I will give some practical examples in the end of this video too. So in continuation, SDH offers higher transmission rate suitable for deployment of broadband optical fiber network. We basically call PON service, that is passive optical network. Then we have synchronized networking. It enables efficient add and drop and cross connect functions. NOC plays a very important role where every equipment is centralized logically in the graphical GUI form, that is called GUI, graphical user interface form. And the most important FCAP feature is inbuilt in this SDS technology, that is fault configuration, accounting, performance and security management, deployed in standard protected ring services, wide variety of interfaces to accommodate PDH and SDS traffic. Then we have simplified and reliable transport network for carrying large message traffic for local as well as global trunk application. So in SDH we will see that from 2 Mbps to even 1000 Mbps or more than 1G circuits are available. This it is very easy and efficient to manage optical traffic around the globe. So we talk about some synchronous digital hierarchy standards, that is defined G707, 708, 709 standards for bit rate, network interface and structure respectively. The basic transmission rate is defined as 155.52 Mbps, around 155 Mbps, and referred as STM, that is Synchronous Transport Module 1. And if we see that in one STM we have 63 E1, each even have capacity of 2 Mbps. So it will come around 130 around or 140. Rest is for synchronization purpose and other monitoring purpose. Similarly, higher transmission rate STM4 622.080 Mbps, that is 155 into 4 times. Again STM16 has capacity around 2.5 Gbps. Then STM16, that is 2.5 Gbps, that is multiplied by 4 again. And even I worked on STM64, that is around 10G, and beyond that we have DWDM concept and OTN concept, so we'll discuss when the time comes. So in this way SDS structure MUX are defined. There's so many OEMs, that is original equipment manufacturers, such as Tejas, Tel Labs, Huawei. Then we have some foreign Ericsson's, Nokia, Cisco and other big companies are Vitella. There are so many brands are there in the market whose ultimate aim is to carry the optical traffic from one place to another. So apart from the SDH, US and Japan use Sonet while rest of the world used SDH. So initially what happened, Sonet was opted by the Americans. So ITU, what they did, they said you are following different standards, so they have make one standard, that is SDH, for this optical fiber communication. Similarly, we have, for Sonet we have STS, synchronous transport signal, and one OCS having the capacity of 51.84 Mbps, and that is into if we multiply 3 it become STM1, which means 1 STM equivalent to 3 STS signal frame. So let's have a quick review between differences between the OC1 STS. Then we have what are the payload and what is the overhead and what is the actual STM0. So we can see that OCS1 STS1 51.84 equivalents to 50.112 that is payload actual data signal or the traffic which is carrying, and overhead is 1.728, so it become around STM0. Similarly, we have STS3, then we have STS12, STS48, STS192, STS768, which is equivalent to STM256. So these are the comparison between Sonet and SDH. For next future videos, stick to this channel.